Okay, look at this first one on the left side. You see that? Okay, you can see here's like the actual graph, and then that's what you would see in a graphing calculator. So it has a vertical asymptote at 0. It also has a horizontal asymptote at y equals 0. So your axes end up being the asymptotes this time. If you've heard that word before, asymptote, you can see it starts with the prefix as. And so here's how you can remember it, right? Is you know that scene in Finding Nemo where like he's swimming and they're like, he touches the boat. They're like, Nemo, touch the butt. It's great, right? Well, this is your asymptote, and so it's like that song, Can't Touch This. Don't touch the butt, okay? That's the goal here, is if it's a vertical asymptote for sure, you can't touch this, okay? Don't touch the butt. Don't be like Nemo, because then bad things happen, right? He's taken away. It's the whole deal, the whole movie. Hopefully you've seen it. Great one. My kids don't love it yet, which is like really disappointing for me. It's probably because it doesn't have music. So like, it's a little sad, but like, it's so good. Okay. Vertical asymptote, can't touch this. Here's what's weird. Horizontal asymptotes, you can cut through, which is why when you'll hear me say like, don't touch the butt. That's just for the vertical one. Horizontal ones, oftentimes we don't touch it, but sometimes if there's like a 3 section or things, there's gonna be one that cuts through it. It's weird, okay? So you can see, here's another example. This one looks a little bit different. 1 over x squared. You have an asymptote here, and then the no, can't touch this, is that vertical one on the y-axis. So you can also see, so here is this would be x equals 0. So this is a vertical asymptote. Vertical asymptotes make it undefined, okay? That's why you can't touch this. Great. We're going to look at some equations today and just make sure we're good with finding the asymptotes. That way tomorrow, when we actually do the graphs, no one cries. Okay. Asymptotes. All right. Here is can't touch this. The graph cannot intersect any vertical asymptote. The vertical asymptote comes from the denominator, because no, we do not want it to be undefined. If the denominator is 0, it makes it undefined. Here's the weird part, again, is the horizontal ones. There can be at most one other non-vertical asymptote, and it may intersect it. Well, then, like, what's the point? It's a little bit weird. It's like some parts of the graph are going to, like, get really, really, really close to that and not touch it. Other parts of the graph might cut through it. And so when we say non-vertical, it could be horizontal or it could be slant. One or the other. You're not going to have both, okay? That's why it says at most one. So you either have horizontal or slant. So you'll see if I have a horizontal, I'll cross out the slant. If I have a slant asymptote, I'll cross out horizontal. Can't have both. You might have more than one vertical asymptote, though. Should I say don't touch the butts, plural, in some situations. Okay, so the vertical asymptotes. If you came straight out of Algebra 2, then this might be less familiar for you. Okay, vertical asymptote. We look at the denominator. You can't have a 0 in the denominator because it makes it what? Undefined. Okay, so you set each factor, so factor first, and then set each factor equal to 0 and solve. And then you'll know what would make it undefined. So you're just finding the zeros that would cause the denominator to be 0. It says if the factor does not appear in the numerator, then it's an asymptote. If it does appear, it's a whole. We'll talk more about that tomorrow. Okay, and then the horizontal asymptote is where it gets weird. You're going to look at the exponents. So look at the degree on the first term and the degree on the top and bottom. So if the degree in the numerator is less than the degree in the denominator, we say that the asymptote is the x-axis, y equals 0. If they're equal, you divide. If it's greater, it means that there is an oblique one, which means it's slant. is usually how I'll say that. We're going to do some examples. I think it'll make more sense. But you're just comparing the exponents to say, like, are they same? Are they different? Which one is bigger? Which one is smaller? And that helps you determine what your asymptotes are. Okay, let's look at these examples. We're going to find all the asymptotes. So start with the easy one, which is no, it cannot be undefined. So you need to look at the denominator, and you can see that you can factor that. X squared minus 16. This is a difference of squares. X plus 4, X minus 4. There you go. If you're still struggling with difference of squares, here's another way to think about it. What multiplies to negative 16 and adds to 0? Positive 4 and negative 4. Okay. And now you can see, okay, look at it again. Nothing cancels out, so there's no holes. Talk about that more tomorrow. If I set those equal to 0, I get negative 4 and positive 4. So you have two vertical asymptotes. When I say vertical, I literally mean that these are vertical lines, which is why you can't just put the numbers. You do have to put x equals because they are vertical lines like this, okay? Vertical, straight up and down. There's two lines that they're going to never touch. Don't touch the butt, okay? And horizontal, you are looking at the first term. So I'm going to look at x and x squared. And I'll rewrite it again just so it's right in front of us. X over x squared. You can see that the exponents here are 1 and 2. Do you see how the exponent in the top is less? So n is less than m, which means that your horizontal asymptote is going to be the x-axis. It's going to be y equals 0. It's in that chart that's right above you. So since there was a horizontal asymptote, there is not a slant asymptote. Okay? You can cross it out. You have one or the other, not both. But you might have more than one vertical asymptote. That's fun. All right. I'm going to let you try the next one. Vertical. There's the denominator. It can't be undefined. So if you were to set that equal to 0, what would cause it to be 0 and cause it to be undefined? Okay, figure it out. Okay, negative 1/2. Again, that's a line. So it's a vertical line that we'll graph them tomorrow. Okay, and now we check the exponents to see, okay, what is my horizontal asymptote? You just look at the first term. So I'm not going to bother with the rest of it. It's 3x over 2x. What are the exponents here? 1 and 1, which are the same. So we say n is equal to m. And when that happens, you just divide the coefficients. So 3 over 2. Okay, so it's going to be y equals 3/2. Okay, you had a horizontal one, which means that the slant one doesn't exist. You can't have both. Okay, and then again, can you do the vertical one for the next one? This one is just formatting's sakes. I split it up a little bit differently. Okay, so you're looking at the denominator. What would make it undefined and make it no? Say, okay, x minus 3 equals 0. What's the asymptote then? X equals 3. Okay. That one is done. And because there was nothing to factor, sorry, I should have said that for the last two. There was nothing to factor in the last two because you had a bunch of linears, and this quadratic on the top doesn't factor either. Okay, the horizontal asymptote. Okay, you compare the first term. So it's 2x to the second over x to the first. Who wins? The numerator, right? The n. So n is greater than m. Yikes. Which tells you that there is not a horizontal asymptote. There is a slant. Okay, so this is when you actually have to do the division. Now you can do long division every single time, but if synthetic division works, I would probably use synthetic division. So here we're doing 2x squared plus 5. divided by x minus 3. So it's, sorry. I didn't leave myself a ton of space. What's the k value we are using? X minus 3, so I would use positive 3. Okay, and then remember you're missing a term. So 2x squared plus 0x plus 5. Okay, so let's just do synthetic division real quick. Good thing you just took a test on that. So that's 6, 18. Do you have a remainder of 23? Okay, good news. The remainder doesn't matter. What does matter is this, 2 and 6. When we're talking about slant asymptotes, we're talking about literally a diagonal line. So it needs to be a line, so it has to be linear, and you have to keep in mind you had a quadratic, and so then it's one less, so it's y equals 2x plus 6. Oh, sorry, you can't really see that. Let me scoot it over. Take 2. 2x plus 6. You only have 2 asymptotes then. You have one vertical, and then you only can have one more, either horizontal or slant. And in this case, it's a slant, which is literally this kind of line, okay? Just so we're clear of what it kind of looks like, okay? Vertical, straight up and down. We are not graphing today.